So, today we will be doing some problems, and most of the problems that I will be doing in this course will be based on the book by Kleppner and Kolenko. This is that book, Introduction to Mechanics, by Daniel Kleppner and Robert Kolenko. So, most of our problems will be from this book, but not for quiz, okay, for doing in the class. So, the first problem I am taking is based on example 1.17, and it says that a particle moves with a. So, first problem is a particle moves in a plane. The problems that I am taking today will be using plane polar coordinates. So, it is a practice of using plane polar coordinates. The particle moves in a plane with standard notations. R dot is equal to 4 meter per second, and you know what is r and what is theta. This is x axis, this is y axis, this is the position of the particle, then this distance is r and this angle is theta. These are the plane polar coordinates. So, r dot means ddt of r is 4 meter per second, and theta dot is 2 radian per second. Theta dot is 2 radian per second. So, this is the data given, and you are asked to find the velocity and acceleration of this particle. Find velocity and acceleration of this point, of this particle. Okay. So, as you know, what is velocity? Velocity has two components, radial components and transverse component. I call this theta cap direction as transverse direction, and r cap direction is the radial direction. So, this is r cap and this is theta cap, although this book calls it tangential acceleration, but tangential would mean tangent to the path, not perpendicular to this radial. So, V is equal to r dot r cap and plus r theta dot theta cap. So, that is the expression for velocity, and r dot is given here 4 meter per second, and r cap and then r, and theta cap is given 2 radian per second. When r is 3 meter, when r is 3 meters. So, that is also in the question. Find the velocity and acceleration of this particle when r is 3 meters. So, you can put this 3 here. So, 4, this is finally it will be in meter per second. So, remember that I am using only the numerical values here, but the velocity will come out to be in meter per second because we are feeding all SI data. So, this is 4 times r cap and plus 3 into 2 is 6. So, theta cap. So, that is the velocity meter per second. This is the velocity. So, this is in this direction the component is 4 units, and in this direction the component is 6 units. If you want to speed, it is just a square root of this 4 square and plus 6 square. So, 16 plus 36, that is square root of 52 meter per second, that is the speed. And if you want the angle, you can always get what is this angle, tan theta is equal to this radial component divided by the transverse component. So, this is about velocity. Then acceleration is the radial component of acceleration is r double dot minus r theta dot square. Right. We must have derived this, otherwise you can derive it, r cap, and the transverse component is r theta double dot plus 2 times r dot theta dot. You know, we had done dr cap by d theta and d theta cap by d theta, we had done this, and then if you are differentiating with respect to time, you also have to finally differentiate with respect to time here. So, theta dot that will, those things will be used here, and then you can get this relation. So, if I put the values here, r dot is fixed. Okay. So, r double dot, which is d dt of r dot, is 0. So, that is 1, and then theta dot is 2. So, theta dot is 2, and therefore, theta double dot is d theta dot by dt, that is also 0. So, this is 0 and this is 0. So, what we are left with, r theta dot square. So, A is equal to minus r theta dot square. So, minus r theta dot square, and this is in r cap direction, and in theta cap direction, it is 2 r dot theta dot. So, plus 2 r dot theta dot in theta cap direction. You put the value 3 here, then theta dot square, that is 4 here, and this much r cap plus 2 times r dot into theta dot 4 into 2. So, 4 into 2 theta cap. So, that is the acceleration, 12 r cap plus 16 theta cap meter per second square. Okay. So, that is how you can get this acceleration. Next problem, problem number 2, and this is based on 1.18 of the book, and the problem is, a particle is moving on a circle with a uniform speed v. A particle is moving on a circle with a uniform speed v, circle of radius r. Find the rate at which the acceleration changes. Find the rate with which the acceleration changes. Okay. So, a particle moves on a circle of radius capital R and with a constant speed v, uniform circular motion. You have done it in standard 11, and you know what is the acceleration. The acceleration is towards the center and is minus v square by r. You can also write from here, the acceleration is r double dot minus r theta dot square in r cap direction, and r theta double dot plus 2 times r dot theta dot in theta cap direction. Since r is constant, the distance of the particle from the origin is constant. You can take x axis, you can take y axis, this is r, this is theta. R dot is 0, r double dot is 0, so this term goes away, and r dot is 0, so this term goes away. Then you have theta double dot, and theta dot, the angular velocity theta dot d theta dt, okay, d theta dt is v by r, because if this is d theta and then this is the v times dt, so d theta by dt will be v by r. So, theta dot is v by r, v is constant, r is constant, so theta double dot is 0. So, theta double dot is 0. So, you do not have any theta cap component of the acceleration, we know it. If the speed is not changing, the tangential acceleration is 0, and here the tangential acceleration is same as that theta component of the acceleration, because here this theta direction is actually tangent to the path. So, this is gone, and then you have minus r theta dot square, and theta dot is your v by r. This r is capital R, and this is v square by r square r cap, and that is minus v square by r cap. So, this result you anyway know. Now comes rate of change of acceleration dA dt, that is minus v square by r is constant, right, minus v square by r is constant, r cap. So, this is dr cap dt, which is dr cap d theta, and then d theta dt, which is minus v square by r. And what is dr cap d theta? Dr cap d theta is theta cap. Okay, we must have done it. So, this is theta cap, this is theta cap, and d theta d dt is this one v by r. So, this is v by r, and then this theta cap. So, this rate of change of acceleration is minus v cube by r square, and then theta cap. This is our question number 2. Next question 3, and this is based on example 1.17, and it says that a particle moves with theta dot is equal to omega, which is constant, and r is equal to r naught e to the power omega t. So, this is the information given, theta dot is omega and r is r naught e to the power omega t. The first part is sketch the path. Sketch the path. So, when you want to get the path, time is not important, we want a relation between the coordinates on which path it moves. So, here it is r is given as r naught e power omega t, and theta from here will be omega t. So, I can eliminate t and write r as r naught e to the power theta. So, that is the equation of the path. And how does it look like? Sketching. So, if you have say x axis and y axis, and at theta is equal to 0, if you take theta equal to 0, e to the power 0 is 1 and r is equal to r naught, and theta equal to 0 means along the x axis. So, in this direction, this is theta equal to 0 direction and r is equal to r naught. So, from here you have to go a distance r naught. So, this is r naught, this small thing is r naught. So, particle is here, when theta is 0, particle is here. Now, when theta is, let us say, pi by 2, as theta increases from 0, e to the power theta will increase. You know what is e theta? E to the power theta, 1 plus theta square by 2 and so on. So, theta increases, e theta increases. At theta equal to pi by 2, this e to the power theta is e to the power say 1.57, and that value is around 4.8. So, that means r will be r naught into 4.8. So, if this is r naught here, theta equal to pi by 2, that means you are here, and the 4.8 times of this. So, I cannot draw it to the scale. So, this is say 4.8 times r naught, and it is continuously increasing here, it is continuously increasing here, it is going like this, it is going like this. then when theta is pi, e to the power theta will be square of this, and that is around 23 that is around 23. Okay. So, this is R naught. When it reaches here, it is 23 times of this. So, I cannot draw on the scale, I can only tell that it will keep on increasing and it will be like this. And then when theta is 3 pi by 2, then this is 110. This is e power theta is 110. So, it ever increases, and this is 110 times this R naught. Theta is 2 pi, e to the power theta will be very high, it is 534 square of this. So, it will go like this and so on. So, this kind of spiral will be there. You can draw a much better work and look at the angles which we will be doing in the other sections anyway. So, this is part A. Part B is find the speed as a function of theta. So, part B is find the speed as a function of theta. So, write velocity. Velocity is r dot r cap and plus r theta dot theta cap. Should be tuned to it and write it quickly. This is velocity. So, and what we need? Speed. So, r dot, what is r dot? R is equal to r naught e to the power omega t, and or you can also say this is e to the power theta. So, r dot is r naught and then e to the power theta into theta dot, right. What we have done? Differentiate with respect to time. This is to be differentiated with respect to time. First differentiate with respect to theta, because it is written as a function of theta. So, differentiate with respect to theta and then differentiate theta with respect to time. So, that is how it comes, and theta dot is known, theta dot is fixed, omega. So, this is r naught times omega times e to the power theta. This is r dot. And what is r theta dot? R theta dot is r naught e to the power theta, this is r, and then theta dot, and theta dot is omega. So, this is r theta dot. What you see is r dot is same as r theta dot. See, r dot is same as r theta dot. That means Vr, r component of the velocity, is same as theta component of the velocity. This thing and this thing are same. The component of this velocity in r cap direction, it's same as the component of velocity in r theta cap, theta dot, in theta cap direction. So, if I am somewhere here on this path, and if this is the r cap direction and the perpendicular to it is theta cap direction, this is r cap, this is theta cap. Now, velocity has equal components in the two directions, and therefore, the velocity should be in this direction, 45 degree to it, 45 degree to it. Our diagram is bad, our diagram is very bad. Okay. The velocity should be 45 degree to the radial direction, the velocity should be 45 degree to the tangential direction. So, it should go like this, it should go like this. Here this is radial direction r cap, this is tangential direction theta cap, and then it should go like this, equal angle from r cap direction and theta cap, everywhere. This is r cap direction and this is theta cap direction, and the actual velocity should be in between. So, it should go like this. Okay. So, just do not go by the sketch of the diagram and you can draw a much better diagram. But the thing is, it will keep on increasing, r will keep on increasing all the time, this equation will be followed. So, speed will be this Vr square plus V theta square. So, this is root 2 times omega r naught e to the power theta, that is the speed. Okay. Then this is part B. Part C is find the angle made by the velocity vector with the radial and transverse, we have done that, so no need. Next part is find the radial, transverse and tangential acceleration. So, write it as C. Find the radial, transverse and tangential acceleration. Okay. So, what is this radial acceleration? Radial acceleration AR is r double dot and minus r theta dot square. This is the radial direction, acceleration in radial direction. What is r double dot? What is r double dot? This is r. So, r double dot is r dot is omega times r naught e power omega t. So, we are differentiating with respect to time and r is given by this. So, with respect to time you differentiate, this omega comes here. So, omega r naught e to the power omega t, that is r dot, and therefore, r double dot is once again differentiate with respect to time. So, omega square into r naught and then e power omega t. So, that is the radial, that is the r double dot, that is r double dot. And what is r theta dot square? R theta dot square means e to the r naught into e to the power omega t, that is r. Theta dot is omega. So, theta dot square is omega square. So, omega square r naught e to the power omega t. Again you see omega square r naught and omega t. So, what is this? What is this? What is this? This is 0. Interesting. Radial component of the acceleration is 0. Okay. So, AR is equal to 0. AR is equal to r double dot minus r theta dot square is equal to 0. R is increasing in a great fashion. R is increasing, is going away from this origin, and it's exponentially it is going away. You can see this is 4.8, this is 23 and so on, this is 500. R dot, if you see r dot, here is r dot is also increasing. So, the rate at which this distance is increasing, that rate is also increasing, but still the acceleration in that radial direction is 0. So, you can have motion in which r increases, r dot also increases, but then the radial acceleration is 0. Transverse acceleration, that means acceleration in theta direction, and that is r theta double dot and minus plus 2 r dot and theta dot. So, go in the same fashion, theta double dot, theta dot is fixed, theta dot is fixed, theta dot is d theta dt and that is fixed, that is omega. Okay. This theta dot is omega. So, theta double dot is 0. 2 times r dot and theta dot is omega and r dot is this omega r naught. So, omega here, r naught here and e power omega t. So, that is the acceleration in theta direction, transverse direction in this direction. This is that theta direction. So, this direction there is no acceleration, this direction you do have acceleration, and it is this much, and therefore, the acceleration is in this direction. Since there is no radial acceleration, this theta cap direction, that is the direction of the acceleration. So, the entire acceleration is in this direction, and this is the magnitude. And tangential acceleration, AT you can write, tangential acceleration. What is that? Acceleration in along this tangent. If this is the path, then this is the tangential direction, and in that tangential direction, what is the acceleration? So, in theta cap direction you have acceleration, full acceleration is in theta cap direction. So, if you need a tangential component, you just multiply by cos of that angle, okay. And since we have seen that cos of this angle is 45 degree, this angle is 45 degree, cos of 45 degree is 1 by root 2, and therefore, this is a theta times 1 by root 2. This is also, this a theta is also a full acceleration. So, this is root 2 times omega square r naught, and then e power omega t, or e power theta if you so wish. So, that gives you the tangential acceleration. Then the next part is show that this tangential acceleration is dv dt is equal to dv dt, rate of change of speed. Okay. In circular motion you must have studied the radial acceleration is v square by r towards the center, and the tangential acceleration is dv dt, rate of change of speed. So, that we generally do for circular motion, but here if I do this dv dt, what is speed? Here is the speed, this is the speed. So, v is equal to square root of 2 omega and then r naught and e to the power theta, which is omega t. So, dv dt is equal to rate of change of speed, square root here, omega here, and 1 omega will come from the differentiation. So, omega square here, r naught here, and e power omega t here, and you match. So, in this case also, even if the path is not circular, the tangential acceleration, component of acceleration towards the tangent is given by this dv dt, rate of change of speed. So, we close the session here, and you can do more practice with the book Klepner if you can get, that is the base book which I am following at least for this problems solving. So, you can do more practice yourself.